So this transformer, understood? So this is a leakage flux J into X1. So why we are represented taken as a leakage reactance called, that is called, this is called imaginary reactance, that is called Fish-Thesis reactance. Okay, that is called represented by J into X1. So for primary side, because of leakage flux, so this reactance is coming to picture. So that is represented by J into X1. And the secondary side also there is a reactance in the transformer winding. So that is represented by leakage flux. So that is called XL. That is called X2. Okay. So that is nothing but here. So for the secondary side, so represented as J into X2. So primary side J into X1. Okay. The primary resistance R1 and secondary winding resistance. This is called transformer winding resistance. Okay, so either maybe small r1 and small r2. So your wish. Okay, so small r1, some cases small r1, and some cases small r2 also taken to account. Okay, and this transformer, the transformer, so core having some losses, that is called eddy current losses. The transformer core, because of this transformer core, so having eddy current losses, that is called watt pull component. So that is represented by WIW. No? So watt pull component. Because of that, then that is one of the component that is called core loss component. That is called, okay, that is represented by, so the transformer RC. Okay, core resistance of the transformer, that is called, because of core, so some losses are introduced into the system, that is represented by, so RC. And also under no load condition, it is does some amount of current, that is called magnetizing current. This, that is nothing but IMU. Okay, so you know well, IMU. This is called IMU, and this is called watt pull component, IW. Okay, so this is because of this some amount of reactance, some amount of leakage reactance, and some amount of inductive reactance coming to picture, that is called magnetizing reactance, that is represented by J into Xm. Okay, core loss component RC, and so magnetizing reactance Xm. So this is called, so you know well, so I naught, that is called no load current, is a combination of okay, so watt pull component and so magnetizing component, you know well, watt pull component and magnetizing component. So this is under no load condition. So this is under no load condition. These all are represented in series with the transformer winding. Okay, these all are represented in series, in series, in series, in series to the transformer winding. In series, okay, in series in equivalent circuits, they are represented in series to the supply. Okay, these are no load branch parameters are represented in shunt. Okay, exactly parallel shunt. This is called no load branch parameters. No load RC and XM are called no load branch parameters. And then so then we will draw the equivalent circuit of transformer, exact equivalent circuit of transformer. Okay, so this is a, so primary winding of the transformer. So winding of the transformer represented, this is called primary winding of the transformer. Okay, so like this, and this is called coupling between the transformer. Understood? So this is the transformer. The number of turns in primary winding is called N1, and the number of turns in the secondary winding is called N2. So this series branch parameters are called R1 and X1. R1 X1 and R2, X2. This is under load side. So these two are, this is our load side. Am I right? These two are R2. So two means secondary side. So these are one means primary side. These all are primary side. So representation under primary side. These two are on secondary side. That is called load side. Okay, secondary or load side. So the primary side. So we are connecting R1. That is called R1. Okay, R1. So then reactance. So represented by like this. So J into X1. R1 and J into X1. So this is called supply voltage. This, and so you are represented like this. If you are considering only series, so only this branch parameters. Okay. So this and 1 and 2. So this is called, so the primary voltage V1 or VP. This is called I1. Okay. R1 JX1 and I1. And the secondary side. So what are the different type of parameters on secondary side? So secondary side R2 and J into X2. This is called R2. So this is called J into X2. So this is called load. The load is connected on the secondary side of the transformer. Am I right? So this is called ZL. So what is the impedance on this? This is called secondary side voltage V2. Okay. V2. This is called E2. So this is called E1. EMF induced in the transformer windings E1. This is called E1. V1. So what is the current here? So I2. Am I right? N1, N2, R1, R2, J into X1. So they represented by like this man. So what about sent branch parameters are connected? So here, okay, sent branch parameters are connected. That is called no load branch parameters also. These are also called as no load branch parameters. So connected. So these are all represented on the primary side. Okay, these two are represented in primary side, and also these are so like this. So this is called RC, core loss component, and wattful component, and this is called J into XM, magnetizing reactance. So what is this current is called I1. So you know well this current, what is this current? I naught. So I naught, you know well, I naught. This is called current flowing to no load branch parameters. So this current is called, what is this current? IW. Current flowing to the this transformer core. This is called core loss component. So that is called wattful component. This is current is called IW, and this current is called I mu, magnetizing current. Okay. So this is called exact equivalent circuit of the transformer. Exact equivalent circuit of the transformer. Understood? So here, so wattful component and magnetizing components are represented parallel to the transformer winding. Exactly parallel. This is called shunt branch parameters. This is called series branch parameters. Am I right or not? Series branch parameters and shunt branch parameters. Okay. So transformer refers to this, you know well, one relation. So what is the relation in a transformer? That is a so turns ratio is equal to, so what is the turns ratio in a transformer? A is equal to N1 by N2. Am I right? This is the turns ratio in a transformer. And also A is equal to, so right, complete V1 by V2 is equal to N1 by N2 is equal to, so that is called I2 by I1 is equal to A. This is called A is called turns ratio. So represented as turns ratio. Another parameter is also there, that is called K. K is called transformation ratio. Transformation. Transformation ratio. So the turns ratio is nothing but A is equal to N1 by N2, and the turns ratio K is nothing but N2 by N1, opposite. Some cases they are given in the problems, transformation ratio of the transformer. It is called K, turns ratio of the transformer A. Okay. So when referred to the secondary winding is secondary, so these elements are referred to the primary side. So what is the multiplication of A square? For example, this impedance is transferred to the primary side of the transformer winding. So this is converted into primary side. So that ZL is become, A square times of, that is called ZL dash. A square times of ZL. No? So when you are converted into primary side, okay, so when ZL is converted into the primary side of the transformer, so that ZL dash is become A square times of ZL. Okay. And also so ZL dash is equal to, and so here A is called N1 by N2. No? ZL dash is equal to, A is called N1 by N2 whole square into ZL. No? So write in terms of K also. So that will become ZL dash is equal to is that is called ZL by K square. Am I right or not? K is nothing opposite, no? N2 by N1. Okay. K is nothing but N2 by N1. ZL by K square. ZL dash is equal to ZL by K square. If it is ZL in terms of turns ratio, so multiplication A square. In terms of transformation ratio by K square. So we'll get like this. So when this secondary side impedance is converted to the primary side, so we are represented like this manner. Okay. So refer to the primary side. Secondary side elements are converted into primary side. Draw the circuit diagram. Secondary branch parameters are converted into the primary side. Secondary branch parameters are converted into the primary side. So in that case, draw the circuit diagram of the transformer. Refer to primary side. Secondary branch parameters are referred to the primary side of the transformer. So in that case, what is the circuit diagram? Here, so R1 is as it is. R1 is as it is, and X1 is called J into X1 is called, it's like this. R1 and X1. Understand? So the primary branch parameters are as it is. So only we are converting secondary branch parameter to the primary side. So that will become R2 by K square and J into X2 by K square and ZL by K square. Otherwise R2 into K square and J into X2 into A square. So V2 by, so ZL by K square or ZL into A square. Okay, so like this. So this is primary side as it is, no changes. Refer to the primary side. No? So secondary branch elements are converted into the primary side. That's why, so primary branch parameters are not changing. as it is. Okay. So that's why these primary branch parameters are not changing, means as it is. Okay. So that is called, this is called RC. This is called J into XM. Okay. This is called I naught, no load current I naught. Okay. And then this current is called what full component IW. This current is called magnetizing current I mu. Am I right? Then now I are converting secondary resistance, that is called R2. So the R2 is converted into the primary side, then will become here in series with this transformer winding. Okay, so how to represent it like this? So means yeah, like this manner. So R2 into A square, that is called A square times of R2. Okay, A square times of R2. So that's a secondary branch parameters, that is called R2 is converted into the primary side. Okay, so that's why it will become A square times of the ZL. That means A square times of R2. Okay, and then next reactance also there. So that is nothing but J into A square times of X2. Right? And then so ZL dash, that is converted into the primary side. No? So this way it's converted into the primary side of the transform. So that is generally represented by ZL dash. ZL dash is equal to, so the secondary side impedance will become A square times of ZL. So it's clear. And here supply voltage V1 and primary current I1. And what is the secondary current here? So here what is the current here? I2 by A. So I2 by A. Okay. So you know the relation based on that. I2 by I1 is equal to, so what is the primary current when you are converting into the primary side? So it will become I2 by A by using transformation ratio. Okay. So here, so represented in this way. You know, well, this called EMF induced in the primary winding is same. Primary side is called E1, you know, well, same. And this is called E2 dash. Okay. This is called I1 dash. I1 dash is equal to I2 by A. So this is called E2 dash. So it will become E2 by A. Okay. So here V1 by V2 is equal to, so A times of V2, no? So this EMF E1, so it will become V A times of V2. So you will get A times of V2 here. Okay, I2 by A means here A times of E2. So we'll get A times of V2 here. V1 is equal to A times of V2. E2 dash is equal to A times of V2. So in this way, this primary winding is referred to the secondary winding converted into the primary side. So it will become A square times of R2 and here A square times of X2 and A square times of ZL. The secondary side, complete secondary side is converted into the primary side of the transformer. So when you are converting in that way, these primary impedance parameters are not changing. Okay, it's constant, is not changing. Okay, as it is. So if you are converting the secondary referred to the primary side, no? All of you draw the circuit diagram referred to primary branch parameters are referred to the secondary side. Secondary side. Draw the circuit diagram, all of everyone. Draw the circuit diagram, everyone. So when referred to the secondary side, so what is the circuit diagram? So all series branch with this R1 become So it is converted to like this manner. So same way, R2 X2 is okay. So right, draw the circuit diagram here in series with this. This is also in series in shunt secondary side. So this RC become R1 become R1 by A square. Here A square times of R2 na. So that is but here R1 by A square. So when you are referred to this primary branch parameters are, so these branch parameters are okay. Refer to this primary branch parameters are converted into the secondary side. Okay, so that will become R1 by A square and X1 by A square. Okay, and RC by A square and XM by A square. Okay, so like that. So based on the relations, you will get like this. Okay, and I naught into A. The so like this we have to represent it. So ZL by, so if it is so as it is ZL as it is, so no changes. R2 is also no changes. J into X2 also no changes. All of you draw the circuit diagram and refer to the secondary side. Refer to the secondary side. All of you draw the circuit diagram when all elements are converted into the secondary side of the transformer. So this is homework. Otherwise, draw the circuit diagram. All of you draw the circuit diagram. Refer to secondary side.